Hello and welcome to another section of the course, more plots and customizations. In this section we'll explore more advanced properties of the Matplotlib library. We're going to introduce more options and we'll look at how to achieve certain visually pleasing results. During this section we'll seek the solutions to some non-trivial problems with representing data when simple charts are not enough. We'll try to use more than one type of graph or create hybrid graphs to cover advanced data structures and the representation required. So let's start with the first video of the section, adding a shadow to the chart line. In this video you'll be learning how to add a shadow effect to the plot's chart lines. To be able to distinguish one particular plot line in the figure or just to fit in the overall style of the output our figure is in, we sometimes need to add a shadow effect to the chart line, or histogram for that matter. To add shadows to the lines or rectangles in our charts, we need to use the transformation framework built in Matplotlib and located in matplotlib.transforms. To understand how it all works, we need to explain what transformations are available in Matplotlib and how they work. Transformations know how to convert the given coordinates from their coordinate system into display. They also know how to convert them from display coordinates into their own coordinate system. This table summarizes the existing coordinate systems and what they represent. Note how the display does not have a value in the column. This is because the default coordinate system is display, so coordinates are always in pixels relative to your display coordinate systems. This is not very useful, and most often we want them normalized into figure or axis or data coordinate system. This framework enables us to transform the current object into an offset object, that is, to place that object shifted a certain distance from the original object. We'll use this framework to create our desired effect on the plotted sine wave. Here's the code to add shadowing to the plotted chart. Let's see the individual parts of the code. We start reading the code from the bottom after the if name check. First we create the figure and axis in setup function. After that we obtain a signal or generate data-sine wave. We plot the basic signal in plot signal function. Then we make the shadow transformation and plot the shadow in make shadow function. We use the offset effect to create an offset object underneath and just a few points away from the original object. The original object is a simple sine wave that we plot using the standard function plot. To add to this offset transformation, Matplotlib contains helper transformations. Matplotlib transforms.scales translation. This requires the package matplotlib.transforms as transforms that we have imported here. The values for dx and dy are defined in points, and as the point is 172 inches, we move the offset object 2 points right and 2 points down. Now we look at the output. For that we run the file in the terminal. So this is the output. Another way of using the function is like this. Matplotlib.transforms.scale transformation here. XTR and YTR are translation effects, and ScaleTR is a transformation callable to scale XTR and YTR at transformation time and before display. The most common use case for this is transforming from points to display space. For example, to DPI, so that the offset always stays at the same place no matter what the actual output, be it the monitor or printed material. The callable we use for this is already built in and is available at figure.dpi_scale_trans. In this video we have added shadow to the line successfully. Awesome! In the next video we'll add a data table to the figure.